All right, let's check out these last three on vapor pressure graphs. All right, so it says, what happens to the vapor pressure of water as its temperature decreases? So it's basically asking about this line. So what's happening to this line as the temperature decreases? And you can see that as the temperature decreases, the vapor pressure also decreases. So we have a decrease here. And then what happens to the boiling point of water as the atmospheric pressure increases? So remember, all these are the boiling points of water. So as the temperature goes up, the pressure also is going up. So these are both going the same way. So it's a direct relationship. So it's going to be increases as well. And then the last one is, would the vapor pressure of water at 120 degrees be higher or lower than 101.3 kPa? And as you can see, as you keep moving it up, it would increase. So it would actually be higher. And again, that's kind of how pressure cookers work. The boiling point of water is higher. There's more pressure in there. So the food's going to cook faster because it's not boiling at the same temperature. So the food's going to be able to get hotter. So this would be, it's going to be higher. All right, so that's vapor pressure graphs. And then these questions in here are very similar to what we were doing before, but this is a vapor pressure graph that has three different things in here. So we're going to be able to compare them. So for example, well, let's go through these questions because I'm sure they're going to ask you about boiling point for all of them. You can see here's 100 kPa, so it's very close to 101.3 kPa across here. So if you wanted to, you can double check that this is correct. Here's water, right? And so at 101.3, water is going to boil at 100 degrees Celsius, which is what we're expecting, right? So you can see that like this one has a boiling point that's lower than water. And then this one has an even lower one. So this one would have the lowest boiling point out of the three of them. Okay, so it says, what will the boiling point of CHCl3 be when the atmospheric pressure exerted on its surface is 101.3? Okay, so it's asking for its normal boiling point. And this is the first one, right? Because it has the H in it. So CHCl3, normal boiling point. It's right on this line. So that makes it nice and easy, right? So what's this line? Looks like it's 60. So 60 degrees Celsius. And then it says, what is the normal boiling point for carbon tetrachloride, which is this one right here? Looks like it's in between these two, and that's 70. So somewhere between 70 and 80, maybe 75. Again, sig figs are working in our favor here, right? Because you can be 74, 75, 76. What is the pressure when water boils at 70 degrees? Okay, so now we're talking about H2O, right? So we have to make sure that we're talking about this one right here. And it says, what is the pressure when water is at 70 degrees? All right, so water 70 degrees is about here, right on that line. And it looks like that line is 30. So it's going to be 30 kilopascals kPa. Which liquid on the graph has molecules that exert the strongest attractive forces on each other? So which have the highest intermolecular forces? Now this goes into some stuff we talked about last chapter in bonding. And if we take a look, which of these has the highest boiling point? It's water. So we can assume that water is going to have the highest intermolecular forces between them because it's holding them together so much stronger. You need to heat it up so much more to make it boil. So water would be our guess for this. And this is, does increasing the temperature of a liquid cause its vapor pressure to increase or decrease? And as we saw before, it's a direct relationship. So if one goes up, the other one goes up. Right, and our last question on here, which of the liquids in figure 1 would be the easiest to evaporate? So which one has the weakest intermolecular forces? Which one has the lowest boiling point? All these kind of questions will lead us to this CHCl3.